Wave behavior. Refraction happens when a traveling wave meets a barrier and part of the total of the wave's energy is returned, so to speak, into the same angle at which it impacts in the barrier. Refraction happens when a wave changes medium. This phenomenon is commonly seen and experimented with light. Snell's law talks about how light reflects and reflects while passing through a medium. Refraction, according to Snell's law, has different characteristics. Number one is that frequency stays the same when the light refracts. However, the wave's velocity, direction, and wavelength changes. The phase of light in a light experiment will change by p-halves if and only if the new medium is optically denser. Refractive index is the ratio of the speed of light in vacuum with the speed of light in the medium. So a bigger refractive index means the medium is optically denser, which causes a shorter wavelength and thus a smaller velocity. Snell's law also talks about the relationship between critical angle and total internal reflection. Critical angle is the angle at which light hits the barrier and all of the light is reflected back into the medium and none is refracted. After passing that critical angle, not all of light is reflected back into the medium, but is refracted at a 90-degree angle. Now let's talk about diffraction and interference. Diffraction is defined as a wave passing through a small opening. Passing through a slit, in the case of a light experiment, causes a visible diffractive grating. This grating is caused by both the phase of the light with relation to the angle and to the interference of the waves. Interference is when two waves cross each other, and depending on the phases of the waves, interference may be constructive or destructive. In order to have interference, the waves must be similar in frequencies, equal in wavelength, similar in amplitude, and have a constant phase. The diffracting grating we talked about is visible in a single, double, triple, quadruple, or any number you want of a slit experiment. However, there is a certain difference between a single slit and a double slit. The diffracting grating can be visible in both, however, they are not the same. In the single slit experiment, the diffractive grating is created by the angle from the slit to the point that you are seeing at the screen. The angle causes the several waves of light to interfere. This interfering causes maxima and minimum depending on the type of interference, which is the type of interference is dictated by the angle at which you are seeing. The double slit experiment is very similar, but the grating is different. It has more maxima and more minima, even though it has a single slit envelope, as seen in the image. We could round up saying that the difference between a simple and a double slit experiment is that in the single slit, light only interferes with itself from that one point source, and in the double slit experiment, light interferes also with the other point source, causing more interference and thus more maxima and more minima. However, as we said before, inside a single slit envelope. And this was wave behavior.